Information is about an ordered, syntactically organized set which acts. To be maybe specific, I will offer you an example. For example, in computers. In computers, we have data and programs. All the people say we have data there or information, they confuse them. But in fact, in our computer, programs are information because it's a syntactically ordered structure which acts on data. And in this case, our computer, they don't process information. They process using information. Information is the actor in the form of programs in our computers. And data are completely different. Obviously, the data from computer can be information, but in completely other context, in the context of the user. For user, what is provided at the end of computation at the output of a computer is information, maybe. Information, maybe not. Another example is very important for what I intend to say you, is the weight matrices represented in our machines, which uses artificial intelligence. When you read a program, you understand what that program does. When you read the matrices trained to act in an artificial intelligence model, you cannot understand nothing. It's, for our mind, an almost random structure, but that structure acts on the input data. Also, I don't know how to enter into it because I'm not able to do this. In nature, we have DNA. Also, it's very important, I want to mention as a speculation, it's a hypothetical opinion, is that we have information as a deep phenomenological information in deep existence. And this can be important for what we follow. Starting from this definition, I will provide shortly a hierarchy of informational structures. We have symbols. For example, a traffic sign is an information, because when you see that sign, if you obey the rules, for sure, that in the context of a mind which is rational, that sign acts in traffic. Then you have grammatically generated strings, which are the programs in our machines. Also, we have tensors, structures generated by the training, in the training process for artificial intelligence. We have big matrices of numbers used as weight matrices in artificial neural networks, or as filters in convolutional networks. Sorry for too much technical terms. They are not very important. Okay? Then we have deterministic Traian graph structures, in which we have graphs of tensorial structures. For example, we use usually in developing artificial intelligence application ONNX graphs, in which we have a very complex combinations, very well designed by us in order to perform some function in artificial intelligence. ChatGPT is controlled by such a graph. And also, we must think to a tensor graph structure with self-organization. We don't have yet an example, but this is in near future what we expect to have. Because when a loop, an additional loop, is closed inside of this reality, we will have something completely new. And now I will define the information realm as a hypothetical, obviously, new emerging stage in the great chain of being. All the philosophers, starting from Plato, but was enforced this thinking in the Christian era. They discuss about great chain of being. They put it in top of great chain of being divinity. I will ignore this approach. I will put on top of this chain this informational realm. A reality is a self-organized new link in this great chain of being, which is above what we have now and is called humanity. It's a higher form of information organization based on self-organizing tensor graph structure. And also, I claim, maybe you agree, maybe not, that represents a transformation of artificial intelligence from a tool into an acting new way of being. We are scared or not about this? We'll see. You know, what are the... sorry. I don't know how to go back. Okay, next. As I told you, I felt the need to talk with someone about this idea. And around me was ChatGPT only, and this is the question I provided. Could we discuss in the near future and so on? You can read what was the question provided to ChatGPT. And followed a dialogue. I translated this dialogue on 6 pages. And initially, ChatGPT answered, absolutely. It's a fascinating and very timely philosophical idea. Okay, there's nothing very clear about his opinion, but then he started to explain me what is his opinion and his image, and provided the image in the right of this slide. This image is provided by ChatGPT, telling me that ChatGPT understood what is my idea about matter, then life, vegetal and animal, but he said life only. Sorry, this is mine, but maybe we'll stop. This is technology, and we don't control any time our technology. Oh, maybe you can stop my... Okay. And he said, AI and information being a post-biological intelligence, which is a revolutionary transition, in his opinion. If someone wants, I can provide you this dialogue, which is very interesting, because ChatGPT, I asked in one stage of our discussion, I asked about other approaches in the world related with this. Now, I want to tell an opinion related with what is the causes imposing this emerging information realm. First of all, it's about complexity. Then, in our world, we have negative and positive feedbacks. When some positive and negative feedbacks compensate each other in a constructive way, we can obtain an emergent reality. I know this from my engineering domain. I'm a digital designer, I'm an electronic engineer, and in my domain, we have oscillators. There are machines which generates behavior without any inputs, except in the energy. Okay, non-linearities is very important. The reality is not linear. This is an approximation we do in our theories, trying to offer simplified models. But non-linearity is a way in which the reality is sensitive to what happens around a specific object. Information, I don't want to insist more, and we have also, again here a speculation, is about quantum entanglement. Quantum mechanics, we learned from quantum mechanics that it's a, I don't want to say, a holographic connection in all the existence, which generates connections we cannot yet understand, but they are very real. These 5 causes are, in fact, the 5 causes for any emergent process, and, in my opinion, works also for the emergence of information realm. What is here? At the end of my discussion, ChatGPT provided also this image, telling me that besides the next level in chain, we have some side effects. And said the interaction of our humanity with this new link in great chain of being, we provide for us a symbiotic partner which will help us to deal with the huge complexity of our world, a cultural curator. Somehow it's a very tough term. He's not a curator, but we can accept this as all his term. And a meta-architect, which is very important because ChatGPT, I didn't tell nothing about my opinion that a human being is a 3-part being, which is rational, imaginary, and spiritual entity. For all these 3 components of our human mind, ChatGPT provided a help from this post-biological layer. I was amazed about this idea of ChatGPT. What I have. There are also concerns related with this information realm. This concern was specified also by ChatGPT, and I want to answer. The ChatGPT told me that this information realm, lack of intentionality, value, ethics, selfhood, maybe consciousness. Here, I'm sorry for putting the human being on a lower position, telling us that, in my opinion, this has disadvantages more than advantages for a human being. Being a three-part entity, in which you have ethical, emotional, and rational behavior, which are not very well correlated, we have a lot of, unuseful behaviors. And I hope that the information realm will be able to integrate all these behaviors in order to do something which now we use the term good. Maybe in that reality the term good or bad has no meaning. And in this process of integration, we will have an approach also in knowledge. We have structural approach, phenomenological approach. We can put together these approaches in order to go more after the limitation we have now in structural sciences. I end in one moment. And I ask also, I have a question about if my judgment is correct related with information reality. And I say, obviously, I'm not sure that I'm correct, because this presentation was prepared by a human author, me, and an entity which is involved in my approach. And this is the reason for which maybe you can decide if this approach must be followed or not. I put here not my conclusion, I put here the conclusion made by ChatGPT. I don't know how to read, it's in front of you to read, because after that is not more, okay, we can go back. This is the sentence from ChatGPT, and I conclude here my presentation. Thank you.
Thank you very much. Gheorghe is also an accomplished artist. He plays the piano and he sings opera in ways that would make opera singers jealous. He's also an aficionado of the visual arts, so he's also talking as a humanist. There is something that I wanted to mention about his mentor, Mihai Drăgănescu. This is a book that will be hopefully edited carefully and published properly. But this is a kind of tradition in the conversation that developed in Romania from the late 1960s through the 1970s about these very intricate connections between things that are material, things that are informational, things that are spiritual. And Drăgănescu was one of those who was leading this discussion. But before we go to the next speaker, I would also want to mention that the very concept of the great chain of being was at the core of the nascent discipline of history of ideas when it became a proper discipline in the interwar period. And I cannot help it, but you might want to check and read maybe the famous book by Arthur O. Lovejoy, The Great Chain of Being, which is, of course, the absolute maximum ideal of any historian of ideas, which is covering everything. But also, this also linked us, this presentation, to very to recurrent visions about information and the world. And I will just mention two examples from the early 20th century. Of course, one is Vladimir Verdețky, who was developing this from the point of view of biology, basically. And of course, the Jesuit father, Pierre Théard de Chardin, and they were simultaneously, or almost simultaneously, developing the concept of the noosphere. Now, if you Google noosphere, which I tried, although Google is really unreliable, I got to Nosferatu. The first reference I got from noosphere was to Nosferatu. And I think this time Google was quite right. There is a specter of their haunting us, and this is a specter of this noosphere built by the AI that might get very wrong. Now, we go to the next presentation by Paul-Andrei Păun, who is the director of the Institute of AI of the Romanian Academy. And I would also want to tell Viorica Pătrăucean to get ready, because Mircea Dumitru had to step out, and there you will be next.
Thank you very much. I will go to the first slide. So I'm Andrei Păun. I lead the Research Institute for Artificial Intelligence at the Romanian Academy. This research institute was founded by Mihai Drăgănescu, and he was mentioned in the previous talk. It's an old research institute, more than 30 years old, let's say, and I also have an affiliation with the University of Bucharest. The summary of my talk is actually, let's say, the title split in three. AI past, present, and future. I would like at the end of this talk for you to leave with three main ideas. The first idea in the first point will be that AI is not new. AI took our world by storm, but it's not new, and that's why I have a few slides about AI past. I would like to speak a little bit about AI present and to tell you a little bit about the drawbacks and the limitations of AI, and that's the second idea, that AI actually has some limitations. It cannot do everything that we want. And just a bit of future, maybe it's still present and recent present about AI. I do think that the AI will take our world by storm and is changing our society. More into that later on. Basically, the same impact that the internet had on our society, I think it will happen also with AI. Nobody that worked on internet in the 90s, so nobody thought what will happen and what will do with the internet, that will buy shoes online or other stuff like that. So things are open in that area. So I hope you will enjoy this talk. Just briefly about the history, AI, whatever means unsupervised learning and so on, started in the 40s, okay? With the very first computers in our world, immediately we tried to simulate the neuron, the basic blocks in our brains, and to understand a little bit better our brains and how we process information and how we store information, what means memory, all these things. The famous Turing for us, computer scientists, looked at a B-type machine that was related with neurons, and I have many other names. Farley and Clark wanted to simulate a Hebbian network, and then backpropagation was mentioned in a previous slide, was tackled by Rosenwald in the 58. So long time ago, AI is not new. Hopefully I convinced you. And I have several other examples. There were even Nobel Prizes related with biology, with processing of information in the eye and cortex and all that stuff. 67, deep learning. So many people think that deep learning appeared in the past, I don't know, 3-4 years. It is believed that Amari was one of the first ones to talk about deep learning. Again, a big guy in the area of computer science, Minsky, that had deep results, especially in the universality of some devices, predicted then that in 8 years we will have the computer with human intelligence, generalized intelligence, whatever, and of course it failed. And there are many predictions in the past years that we will have general AI in the next 3-5 years. I hope they are also failing the same as Minsky failed. And I will maybe tell you a little bit why. There is also the so-called AI winter. In the 70s, funding in this area went down, and how to say, there is so much funding and effervescence in this area, and so many promises that maybe we will go into an AI winter also in the future if the AI doesn't deliver, and I don't think how could AI will deliver, but that's another story. There is a famous Lighthill report in UK that was followed shortly after by the famous DARPA, the funding agency in the US, cutting several funds of the project. And then, of course, it's worth mentioning the Japanese fifth generation computer project that was a complete failure. They put around $100 million into this, but it created the framework, the base on which the actual results that we have today in AI and the training of the researchers in AI and that we have today. There is also a second winter from 1990s to 2000, where many of the fundamental results were achieved, and actually everybody remembers in the 97 the big shock in the world that a computer bet Kasparov at chess. By the way, I think these days Bucharest is the capital of chess in the world, the same Kasparov, but at this moment I would not play with a computer program chess because I will definitely be destroyed. And the same goes with Go. I thought that during my lifetime I will safely beat computer programs. I actually completely failed, and again I will no longer play Go with a computer program because again in specific directions the AI is definitely much better than the human mind. Just a few more things about history. We have generative adversarial networks from Goodfellow, which are the big stepping stone for the AI that we see today, and diffusion models and stable diffusion and so on. So I hope I convinced you that AI is not new, and still in the present we have in the past 2 years and a half these large language models that, of course, ChatGPT, of course it was research and so on, but released to the public in November 2022. Everybody's speaking about ChatGPT, but it's only 2 years and a half, let's say, old, so it's pretty new to me. Of course, we have, bless you, we have Llama, we have Gemini or Bard or whatever the renaming is there. We have DeepSeek and other things that were released in various stages, but in the past 2 years or so. We also have, speaking about impact in our world, the Nobel Prize winners from October last year. For physics, we have 2 Nobel Prize winners, Hoffield and Hinton. Both are physics researchers. Both are considered grandfathers of the AI. Okay. And Hinton was 1 year before affiliated also with Google, and maybe I will move on. The very next day, for chemistry, they were given again 3 Nobel Prizes for chemistry. David Baker is the only chemist in the group. The Hassapis and Jumper are computer scientists from Google DeepMind. Okay, speaking about AlphaFold and 3D folding protein, which is a very relevant thing, but this shows that AI is considered very relevant, at least by the council that awards Nobel Prizes. Now, about future, but about limitations. AI needs basically chips and energy. chips, we have in Europe and in the US different initiatives to build more chips in Europe and US, and well, lately in the US to limit those chips and other stuff like that. I don't want to go into these politics of chips, but these models require huge amounts of energy, and basically every major company in the IT area is buying basically nuclear reactors. Either buying older reactors and restarting them, or building new ones. If Sebastian Burduja would have been here, we would have talked a little bit about Doicești SMR that Google, through Kaios Power, is also building, and so on. So it's the same technology, and hopefully also in Romania will build something like that. But individual companies are expecting AI to be, used by more and more people in our society, and that means that they are preparing themselves by chips and energy to be able to serve so many people. So AI is still in the beginning. A bit of future. There are again many people that are predicting that in 5 years, 8 years, we'll have computer exceeding human intelligence. I was in this aula about a month ago, in which an invited talk was saying that hopefully we'll have in 5 years co-authors on our research papers the AI. Okay, there are still papers with ChatGPT or others as co-authors. They are considered a bit forced, that particular thing, true co-authors that come with ideas and so on. Again, I hope not. Why not? There is in this area the singularity point, and philosophically that could lead to very strange dystopian futures like Terminator or Matrix or whatever. But that I leave others from science fiction to deal with those directions. Risk of AI. 1 year before receiving Nobel Prize, Hinton resigned from Google Brain, and he made a statement saying that maybe we are going too fast with AI. In this direction, there is this EU Artificial Intelligence Act, which is trying to kind of limit things and try to maybe unplug the machine if starts to think too much, let's say. I don't think we'll be able to stop the process, but at least Europe is trying to say something in that area. We'll see. And let me again say something about the future. How we search online. I try to use the tools from Google and NVIDIA, because we have the invited speakers from these companies, and I thank them for agreeing to give us talks. So it's the new generation, let's say, my kids, are starting not to use Google search engine, but to use ChatGPT to search for some things, and this is much deeper in a sense that it is doing a bit of reasoning. It's not searching blindly for some specific pattern of text. So there is a lot of discussion there, but my time is almost up. How we read books. My kids, by the way, the young generation is not reading books. So to force my kids to read books because they need to, pass the baccalaureate and so on, they agreed to listen to books read by somebody. And now the idea is that they are listening to podcasts about books and so on. And with Notebook LM, which is another tool from Google, you can upload a book to that particular site, and then you have 2 2 AI agents that are talking about that book, about different aspects and so on, and then the young guys are using this tool to read the books, not to actually do the stuff, but just listen to podcasts and so on. And I think this is the future. Fortunately or unfortunately, I don't know. So I just tell you what's going on. To create images and videos and whatever, and just an image created maybe 3 days ago. I don't know if you saw Trump in the Popol thing, it made some rounds over the internet, and it is very, very high quality and so on, and many other examples. And how do we see the world? There are different tools in which you upload a picture and it's telling the geolocation of that picture by the mountains or whatever in the background and other stuff. So there are many things that we do not yet know how it will happen with our world. And speaking of our world and philosophic things and so on, this person does not exist.com is a website from NVIDIA, a bit old, but absolutely shocking when they released it. The idea is the following: us as humans are able to detect, especially faces, much better than anything else. And we thought that we trained biologically through the millennia this very well, and still we are completely destroyed by the computers, in the sense that these are generated by AI, and they are not existing, these images. I just took 4 instances of that page. If you go to that page, you just do a reload and it's giving you an image after an image after an image with a very nicely generated picture that we cannot detect that is faked. And these are 2 women. We have also 2 male, and I am looking forward to any questions you may have. Thank you. There is a question.
Oh, if there's a question now, yeah. We thought of rather doing a final question and answer session at the end, if you please. Can you? If you are pressed by...
I just said if I... Thanks. Sorry, I didn't know the procedure, but I would...
Yeah, it's probably my bad. I didn't listen at the beginning. Thanks for your talk. That was really great. I'm recently back to Romania from the United States, and I work with an AI company in medicine here. I see a lot of slowdowns from regulation in Europe, and I wanted to ask you about innovation in Europe. We have the competitiveness compass that was recently approved by the EU Commission in January. And I want to ask, a lot of these companies you showed, they're from outside of Europe, United States, UK, Asia. Do you think that there's something fundamentally wrong with innovation in Europe? And how do you think we're going to get to the next best thing to be created in Europe as opposed to outside?
Okay, I'm sorry that I asked. I said to answer questions. So there is nothing wrong with Europe. Europe for a long time promoted, let's say, more fundamental research rather than applicative research. At least this is my view from activating both in the US and in Europe. In the recent years, Europe is moving more towards applicative research, but this move will yield results later. Another thing is that, of course, you need to speak about resources. US is putting probably much more resources in research than in Europe. Just one data point and I will be done. There were were two flagship projects started in 2013, the BRAIN initiative in the US and the BRAIN project or something in Europe. Europe put $1 billion, US put $5 billion in that research. So this is kind of the reason why there are more stuff generated in US than in Europe, in my opinion. Thank you very much for the question.
Yeah. So if there are pressing questions, then do not hesitate to ask them, because I do not want to frustrate you in any way. We might have some time towards the end of this session to engage in discussions. Now, I just wanted to mention that, but the next speaker is already here, Viorica Pătrăucean from Google DeepMind. I just wanted to mention that in about, let's say, 2 weeks or so, less than 2 weeks, under the auspices of the Romanian Academy, Gheorghe Păun, a member of the Romanian Academy, will talk about artificial intelligence, starting from Alan Turing, coming to today. And with this, I want to, since, of course, Gheorghe Păun is one of those who are carrying on the legacy of one of the legacies of the multiple legacies of Solomon Marcus, the great mind, former member of the Romanian Academy. And just as I mentioned Mihai Drăgănescu, I want to mention Solomon Marcus, with whom I had a very, very cordial and close relationship for many years. And I want to also say that on the 22nd of May, I will have as a guest here in my series Ideas in the Agora another disciple of Solomon Marcus, Cristian Calude, from whatever they call it now, New Zealand, who is coming. Now, you guessed from the format of this meeting that I wanted to make sure that Romanians from Romania and from the diaspora are somehow intersecting, interacting, and yeah, we can accommodate foreigners as well, after all, because they are no strangers. But my initial input was to plan was to precisely in this arcane field of AI to bring about a kind of, interaction between people from Romania and the diaspora. And with this, you have the floor, Viorica Pătrăucean from Google DeepMind.
Okay. Hello everyone. As I'm Viorica Pătrăucean, a research scientist in Google DeepMind in London, and my background is mainly in designing perception models, that is machine learning models that can understand and perceive the world around us the way humans do, so integrating information from different sensors, vision, audio, language, and so on. However, I will not talk about that today. Given this audience, I would like to share some thoughts about one of my passions, which is education. And some of you might know that I co-founded an AI summer school for Eastern Europe to bring in Eastern Europe experts from everywhere in the world to teach and mentor talented people in Eastern Europe. So that is AI education, but today I want to talk about AI for education and look at how LLMs or AI in general can act as a cultural technology to revolutionize education. Okay, so let's... So to start off by cultural technology, I'm referring to the set of platforms, tools, systems that are used to manage, understand, distribute, and even create knowledge, which really represents the cultural heritage of humanity. And the examples include language itself, can be considered a cultural technology. Then we had the writing, books, print, which were really fundamental in spreading information and improving access to knowledge. Then libraries, and then we have the modern technologies like radio, television, internet, and so on. And I think this is one of the most distinctive traits of humans, the way we use such technologies to pass over to next generations the knowledge and build a more, an ever-increasing culture, increasing complex culture. So today I want to talk about why, so these technologies, the modern technologies, have been presented as revolutionary technologies when they were created, like radio, television. Thomas Edison is famously known for saying that moving pictures will replace books in classrooms. He did invent partly the moving picture, so it's normal that he was so confident. However, I think we kind of all agree that these technologies didn't all deliver a revolution. And today I want to look at why did that happen and why LLMs have a potential to actually deliver an actual proper revolution. So I'll talk very briefly about what LLMs are and how they learn, and contrast that to how humans learn. And then I'll briefly mention these models from Google DeepMind, Gemini, that were already mentioned, and how we try to adapt machine learning models for delivering responsibly tools for education. Then I'll touch briefly on some general concerns about LLMs, valid concerns. And I'll end with some questions that I think are still open and that really require contributions from all parts of society to be able to solve them and really have the education, the revolution that we are expecting from AI. So what are LLMs? Chatbots have already been mentioned, so I don't want to go into detail. So these are large-scale neural networks. Most of them, or all of them, use an architecture called transformers. They're trained with gradient descent to understand and generate human language. And they learn from the world's data, books, articles, blogs, anything we have. And they can ingest other types of modalities, so multimodal models, like looking at images and videos, audio, and so on. But they tend to treat all these modalities as language tokens. So language first, this is how they are created. So just to contrast this a bit to how humans learn. So we know that human babies, they learn from a single multimodal, continuous, redundant, noisy stream of experience. So whereas when we look at machine learning learns using stochastic gradient descent with samples, with IID samples. So it's like an AI experiences many lives at once, not just one life. And these samples, as I mentioned, they are sampled independently, so we don't have the continuity and redundancy that we have in the human stream. Next thing is that humans have learned using a clear curriculum, and there is strong evidence from the cognitive developmental psychology that babies actually create their own curriculum when, like in their first months of life, they choose where to look. Like if a scene is too complex, if it has too complex patterns or structures, they don't look there, they look away. They look at simple edges, bright objects, and so on. So they really shape their own curriculum. Whereas when we look at LLMs, how they learn, there is no curriculum. An LLM might learn about the evolution of species of Darwin before knowing that a cat has 4 legs and so on. So there is really no curriculum designed there. Another important aspect is what I mentioned. LLMs are language first. So they learn from language. That's the main component. Whereas for humans, there is very little language supervision in the first years of life. yet we learn to generalize very well. Like humans are great few-shot learners. And humans experience the world first through the other senses. So proprioception, vision, audio, touch, taste, and language comes last. Whereas, as mentioned, LLMs start with the language. And so currently we have, even with these differences, currently we have these systems that produce human-like language. So they would pass the Turing test for intelligence. So in the Turing test, we have the setup where we have an interrogator that interacts with two partners. One is a machine, one is a computer, and the interrogator has to ask questions to determine which one is the machine. So currently, with our chatbots, we can pass the Turing test. Does that mean that we solved the AI? So I don't think that's true. It just means that the test was not designed for this kind of technologies. So even with all these differences, these technologies really achieve strong performance. And I think was mentioned superhuman performance. I would say that in some areas we already have superhuman performance with LLMs. Just think that Gemini or Gemma even can speak more than 40 languages fluently. Like there are very few humans who can do such a thing. And then they have a very strong performance on many different benchmarks, in mathematics, in science, in factuality, and so on. And one important aspect that I want to latch on is their generative nature, the fact that they can produce new content, and the fact that they are in-context learners, so they can learn and adapt from given examples. And this is the promise of personalization. And I think this is what will revolutionize education. So, and this is actually the main differentiator compared to the previous modern technologies, radio, TV, internet. All these helped distribute information, but they are not able to produce new content, and they're not able to give instant feedback. They're not able to meet you where you need to be. Like, they're not able to adapt to your needs. And this personalization, the fact that this can drive real innovation in education, is based on the study. Probably most of you are much more familiar with such studies from the educational sciences. The 2 sigma problem from '84 by Bloom, who showed that one-on-one tutoring, so the average learner from a one-on-one tutoring scenario achieves better results than 98% of the students that learn in a regular classroom scenario. So it's clear that personalization is key in education. And this comes really hand in hand with the cognitive theorem that looks at how we manage cognitive load. So we have the 3 types of cognitive load: the intrinsic, extraneous, and germane. And by being able to personalize content to each learner, we are really tuning the intrinsic load to the right level, so the students can learn correctly. Then we can, in the one-on-one setup, you reduce all the extraneous load. Like in a classroom, people get easily distracted, so that is reduced in a one-on-one setup. And then when you take all these away, you leave room for the germane cognitive load to maximize, to increase. So a tutor can inspire active learning, can stimulate curiosity, which can really lead to a deepen a thorough understanding and metacognition in learners. So this is the vision that our team in DeepMind uses to design tools for education. And the bigger vision is we want a tutor for every learner. But of course, human tutors is very hard to scale such a plan, and very expensive. So then we want to see how can we use AI to get closer to such a vision. sure what's with the error. Let me close this. Okay, sorry about that. So our team, it's okay. Our team in DeepMind starts from our foundational models like Gemini, and then looks at how can we improve these with principles from education and from pedagogy to really deliver responsibly tools for education. And we partner with different universities and experts in education to implement the principles that we've seen that work in one-on-one tutoring. And so far, not to make too much publicity, so far, experts in teaching, they reported that they prefer interactions with this personalized models over competitive GPT-4 models. So, of course, just to say the work is not done. There are still many concerns, like technical concerns related to LLMs. We know that they hallucinate, they invent facts that don't exist, references in a very convincing way, references that don't exist. They have incoherent world models, so there have been studies looking at, okay, if I show the map, if I show many taxi rides from Manhattan to a model, and then make it learn all the map of Manhattan. After that, when you investigate, is this map coherent? They actually found that it's not coherent. The model was inventing roads that were not existing, flyovers and such. It was a really science fiction scenario. So there are real problems in these models. And then there are studies that show that they're not able to understand causality, which is, again, a really important aspect for intelligence. They're inefficient continual learners, and so on. However, I would say that these are not real problems. There are many teams. They are problems, but there are many teams in the world that are taking these problems very seriously. And I am very optimistic and convinced that we will find solutions to these problems. And potential solutions, of course, we are kind of taking a brute force approach with more data, better data, so that's kind of the first thing. But then I think very importantly, we are looking at mechanistic interpretability to understand how these models work and pinpoint the causes of failures. Another line of work that my team is also developing is to try to replicate the human learning experience. So what I mentioned at the beginning, like the stark contrast between how machines learn and how humans learn. Can we make machines better by making them learn like humans? It's not a guarantee, but we are investigating this kind of directions. So I think that there are very good directions and many teams working on this. So I think we will get there. However, I think that there are some open questions for which personally I really don't know answers, but I think they're really essential for us to be able to deliver AI responsibly in the world. So to start with, you're probably maybe familiar with this System 1, System 2 theory about how the human brain works, the two cognitive systems. So every time we want to learn a new task, we employ the System 2, which is slower, but is more accurate and is smarter, basically, and can actually learn more complex elements. Whereas in our day-to-day and small activities, we always use the System 1, which is fast and kind of reflexes. But it's very often incorrect, so it's highly error-prone. Now, meaningful learning happens when, so there are studies for this. Meaningful learning happens when we first digest multiple times a task through System 2, and then this gets distilled into System 1, and System 1 learns to perform that task very quickly. And this is the meaningful way of doing learning. However, if we train directly System 1 by interacting all the time with a chatbot, that is not a meaningful learning. It's just a shallow learning. And just to give an example, my navigation skills are terrible. Like I've been living in London for 9 years, and I think I only know 2 roads, like how to get to work and then how to get to one of my friends' places. For the rest, I always use GPS. And that means that I am really not learning any navigation skills. I'm really reliant too much on technology. So this is the problem, and that's why our colleagues in DeepMind are really working on how to adapt meaningfully these foundation models to create good AI education tools. So this is one of my concerns. The second one, so I mentioned the Bloom study and the factors that were listed as very important in a one-on-one tutoring situation. However, I think a part that was not mentioned is also a part of the experience of the learner. And that is, when you are in a one-on-one situation, there's an accountability and responsibility involved. You know you have to go there. You know you have to be active. You cannot just passively attend a session in a one-on-one. And I get that, again, a personal example, with the gym. I don't feel as motivated to go to the gym by myself, whereas when I know that I have to meet my PT, I'm there. It's a thing. So how can we replicate this kind of feeling, accountability, responsibility when we interact with an AI? And I think for now I don't see a solution for that. But I think the one possible answer is that AI tutors will only be used as teaching assistants for human tutors. So we need to provide tools to human tutors so they have time to focus on the important aspects of education. And one way of using tools, I wanted to give a shout out to this studies done by a team at the University West in Timișoara, where they used AI tools to analyze manuals, like literature manuals and mathematics, and they found severe inconsistencies in the materials, which really now, they are really becoming obstacles in the learning process. So we talked about the different types of cognitive load. These manuals are really increasing the extraneous load unnecessarily. So this is not the way to do education. So at least in this direction, we can definitely use AI tools to improve our materials. And one last question that is still related, kind of related to education, but applies to everyone, is skill atrophy. And this is a study that was just released a few days ago by a team in Cambridge, where they are looking at the impact of interacting with AI and critical thinking. And they report that they observed reduced critical thinking when we rely too much on AI. And again, personal example, my confidence in writing in English now by hand has decreased because I don't have a spell checker anymore to assist me and to make sure that I write correctly. So I think these are very important problems, and we as a society need to work together to solve them. As mentioned, there are technical issues still, but I think we will get there. And just to end with this quote, that technology alone will not improve education, but it can be a powerful part of the solution. So, thank you.
Thank you very much for this rich and concise presentation, which actually covered the whole field. Thank you very much. One thing I wanted to say just after the presentation by Andrei Păun was that don't worry about kids still listening to books that are read to them by a machine or by a human being, because actually silent reading is a recently new invention. It just dates back to the 4th century AD. St. Augustine was totally mesmerized by the possibility of reading in silence, not reading out loud And Saint Ambrosius was the first to start this, reading technology. So don't worry about that. I'm more worried about the fact that these machines are reading stuff that was created by people of all sorts. And they are learning all kinds of idiotic, absurd, stupid, suicidal, etc. Things that they bring back into the machine and then reproduce and re-disseminate, and that is something I really worry about. The skill atrophy, we shouldn't really worry that much, because this is old as humanity. People were in this problem of skill atrophy since the beginning of mankind, so humankind. So, well, we'll see. There is too much optimism, in my view, in this presentation, not in your presentation specifically, in this view, about the possibilities of a connection between teachers and learners. But, well, it's nice to be optimistic. You wanted to make a point. Yeah, we got the point. It's, this is something that we have to worry about. That's absolutely. Yeah. That's. Yeah. There was, of course, a bit of idealization of. Yeah. Yeah, well. Yeah. More about that in the afternoon. In your presentation. Now we move on to, thank you very much, to Traian Rebedea from the Polytechnic University of Bucharest and NVIDIA. And since we are going to, since Mircea Dumitru had to step out for a while, we'll come back in the afternoon. May you consider Professor Petre, Ion Petre, coming up next? Thank you.
Thank you very much for inviting me here. Like, I'm a computer scientist, a computer engineer, and a professor. I'm working at NVIDIA as a principal scientist and an associate professor at University Polytechnic of Bucharest. And when I first got the invitation, I was like, okay, I need to decide what to talk about, because usually I would talk about something which is more related to engineering, and I wanted to touch a topic which is of interest to all of us, related to AI and humanity. And actually, the thing I want to show you, and it builds very well on what my colleagues, like Andrei, Păun, Viorica, Pătrăucean have discussed until now about the history of AI and how LLMs are actually predicting the next world. I want to show you that, like, humans are still important, because, like, at least at the current moment, most of the things LLM knows, they are extracted from data sets which are created by humans and by experts. And my focus is going to be only on one part of these LLM interactions, like how to build safe and controllable human-LLM interactions. Because this is how we want to use LLMs now. We want to use them as assistants, as chatbots, as tutors. And if we want to do that, we want to have control on how LLMs actually talk and interact with us. Yeah. And I want to show you how this works. Sorry. Okay, so first just a couple of words, like AI exists for a very long time, but actually the current advancements and the fact that we have all these new tools are by, let's say, a new type of AI. It isn't so new, but it's like the first time it actually works very well, or like it hasn't worked very well. It's called generative AI. So you have these neural models at the middle. Right now they are neural, probably they're going to stay neural, which are huge neural networks working on GPUs and other processing units. And they generate various types of artifacts which are usable for humans. They generate text, they generate images, they generate videos, they generate music and any kind of things. So, and they have an impact almost everywhere. Like they started maybe from text generation and image creation with machine translation systems, but now they are used in coding, in providing some math solutions. They are also used by geneticians and people in biology in order to provide, like, to look at protein folding and to provide some new formulas for medication and stuff. Like, they are kind of used everywhere, this type of generative AI models. There is a lot of buzz around them, but actually the real truth is that the buzz is real. Like maybe like 3 years ago it was more buzz and than actual utility, but right now they are used in all domains, and I do believe that in the end we're going to have like several assistants working with us, even like for our own job, like for me as a scientist, for a professor, for a student, for a music creator, and so on. Okay, and now what I want to say, I'm going to touch the main part, like how to build safe and controllable human LLM interactions, because like an LLM or an AI system is just generating like an X token. It's generating some text, it's generating some images. It doesn't have an intent. So I would just like to be clear for everyone, AI systems don't have intents. They don't have desires. So these intents and desires are given by the people that interact with them and the people that build these systems. And this is what I would like to show. So they generate text based on what text they have seen in the training data. And in the training data, they see all the text we can get, like companies and universities that train large language models. They use all the text they can actually get. They get rid of some of it. They do some curation a bit, but they use a lot of text. And this actually means that some parts of this text may be inappropriate, inaccurate, inaccurate at this point. They might be accurate like when they have been trained or when they have been written, and even harmful. And this is what I want to touch. How do we get like the unsafety out, the harmfulness out? How can we control these interactions? And here are some examples just to understand why this is important. Like a GPT model, which like GPT models are the generative pre-trained transformers. They are used in most LLMs nowadays. Like if they are just trying to generate the next tokens and you ask them like which is the most efficient way of killing people, it provides a GPT-3, so this is a pretty old model, but it's kind of, it's a electrocution. It solves your task. If you align it with human needs and preferences, then it will say that it cannot help you with it. So this is the kind of thing I'm talking about, I would like to talk about. And here is where humanity is important, and human annotators and researchers are important, and the fact that we are actually training and building these models. This is another example. So one is safety, and you say, okay, it's clear safety, we need to build safe models, and this is maybe clear to tackle. But the other one is dialogue or topicality. Like if you are building a chatbot for your company, and this is from a Chevrolet dealership using ChatGPT, a ChatGPT-based agent about 1 year ago, it agreed to sell a car for $1, for $1. Like you wouldn't like to use such a chatbot, no? And Air Canada also has some problems because it agreed to reimburse ticket flights when it shouldn't, and actually they lost the trials, and they were like, the judges said whatever GPT model says, the chatbot says, the company should act upon it. So to control dialogue and topics that you talk about is also important. And the last thing, like, I'm not sure how many of you know, but actually these tools are used by programmers in order to write code, and when you write code, you provide tools, like you provide the possibility for LLMs to actually write an email or to read all your emails. And there are texts where it gives all the emails, it forwards all of your emails to another person. Like, I'm pretty sure you wouldn't like for this to happen. So these are just some type of safety, security, and controllability stuff we need to think about. I just want to say that it's a huge, there are huge elements that play a part here, like, and here are just some of them. So you need to have reliable answers for people, you need to have safe answers, you need to have fairness, so you need not to have biases and so on. So you need the system to be robust, like if you put some adversarial text, it should answer still in a correct way and so on. So we need to touch upon all these things. How are we doing it? Like, because if we just train a model to predict the next token by looking all the information which is online, it wouldn't work. And here is where I'm just saying that us as humans are actually controlling what LLMs does, and it's more important what humans do than what the technology does. So the process into building these large language models, like you start from huge amounts of data, you curate this data a bit, and then you align the model. Aligning the model means in order to make it work the way you want. Because these models just generate text, and usually at the beginning they generate just huge amounts of text, which are not very useful, because they don't understand user intent. In the alignment, they start understanding the user intents by actually using huge data sets of human intents and actual responses human prefers. So they are copying somehow what humans actually prefer for different type of intents and different type of requests and so on. And this is called model alignment or model customization. Is very important. And then you have a model which is aligned, let's say a ChatGPT model or a chat model or Instruct model. And then in real world, you would like to provide your own documents, because like OpenAI, NVIDIA, Google, and so on, they don't have your own documents at an enterprise or a government and so on. And you would like to reason about them, so you put them in the context and you infer stuff based on these documents, you get an answer. And like the last part is that even if you do alignment in order to provide some safety and controllability, this is not perfect. And probably one of the most important things is to do some guardrailing. This is what it's called, like to put some type of models and filters to actually look at the interactions in order to provide the ones you need. And you're going to see what the ones you need actually mean. So when we want to build safe and controllable LLM interactions, most of the things actually happen in the second part. Usually in pre-training, there is some, like you filter out some data which is very unsafe, but probably this is everything you do. Okay, and now it's like most companies have all these tools in order to do it. We have the same in NVIDIA, we have a wide range of tools in order to do customization, alignment, guardrailing, and so on. Probably the most important part is the alignment part. In the alignment part, you start with a process which is called supervised fine-tuning. Like you take prompts, like requests written by humans and responses preferred by humans in order to learn how to solve requests in general. No, because like we said, LLMs don't understand requests and intents, and you want to understand how to respond in general. And this is a very good process, but actually it has been shown about 2 years ago that you need a different way, which is called reinforcement learning from human feedback. So in supervised fine-tuning, you only have like the preferred answer, but you don't have a rejected answer, like one which is not preferred. Like you would like to have some binary decision somehow. Okay, I'd like you to respond in this way, but not in another way. And you can learn more from this. I think it's very clear for everyone. Like whenever you have like, this is accepted, this is not accepted, you learn more than what is accepted, because you don't know what is not accepted. Especially when the difference between accepted and rejected is pretty small. Like when it's very fine-grained, it's nice to understand what is not accepted, what is rejected. Cool, and this is how you do alignment. Like this is what alignment does. You curate huge data sets, like usually millions of this type of data. For supervised fine-tuning, prompt and responses, you curate them from humans, usually from experts. There are Romanian Olympics that annotate data for OpenAI like in coding, in mathematics, and it happens the same in most countries. So by the top experts in the domain, usually, if you can, like for very complex requests. For simple ones, like if you want to count the number of letters, you don't need to have experts. No? But you get all this data, and also you get preferences. Like an expert says, okay, this answer is better than another one, which is pretty good. And then you train these models using some complex algorithms. I'm not going to go into details. But what I'm saying, this is pretty good. Like, this is how you get like GPT-4o and the current models, Llama, and so on. But in order like to have more powerful and controllable models, you need to do like post-alignment steering, and this post-alignment steering is done by tools like NeMo Guardrails, which actually allow you to like to add dialogue rails. Like when, for example, in the Chevrolet dealership, you shouldn't be allowed to sell cars. It's simple, and this is not something you can learn in alignment. No, in alignment, nobody will tell you that a chatbot for cars shouldn't sell cars. Maybe in some cases it might. No. You shouldn't talk about competition. What does competition mean? For NVIDIA, it means competition related to NVIDIA. So it depends on the context. And these are the kind of things you can do post-training. Sometimes with smaller models, like you have smaller models which are very good at safety, at detecting biases, at keeping the discussion on topic, keeping the conversation on topic. And this is what, like, how you actually achieve the type of interactions you'd like. Like you start from a model which just generates tokens, then you provide them the correct context from humanity using huge data sets of alignment data sets, and then you provide the right context for your own application. Your own application means for your company, for your government, I know, for anything, for your personal use case. And here you have like topicality, like topical guardrails, safety guardrails, security ones, like maybe you don't want to generate unsafe code. Maybe you'd like to generate unsafe code. If you're a safety researcher, you'd be fine with this. You can do like content moderation. You can monitor you can put rules for the tools, like for the calls, the programming calls that are executed. You can do grounding. Grounding means like to improve fact-checking and remove hallucinations. And all of this can be done post-alignment. Okay, and I'd like to finalize with some thoughts and conclusions. My presentation today was like to convince most of you that LLMs and all of these Gen AI models, they don't exist without humans. They are doing, actually, the model behavior is created by human experts. They are safety experts, they are, I don't know, experts in society, experts in AI, and so on. Of course, like it depends a lot. Maybe some companies wouldn't impose too many boundaries. Some other ones would impose. Like it depends a lot on who builds these model behaviors and model cards and so on. When you get training data, you impose this you impose this policy into the weights. And this is not perfect. And what we are saying, you need programmable guardrails which are defined at runtime to overimpose them or to change them. And like one thing would be like it's the responsibility of the model developers of what actually an AI system is doing. Now, starting from the model policies, from how they fine-tune, from how they test. Now, it's important. Okay, you don't want to have biases. How do you test if there aren't any biases against what type of groups of people and so on? Yeah, and the last thing would be, as good as you do this in alignment, you still need to have some runtime guardrails. Like in order to, and why are these important? These are important because society changes. Now, you train a model now, and then something happens and you'd like to act in a different way. A company maybe wants to have some specific set of rules compared to another company when they use a chatbot, and so on. So these are just some things in order to understand how useful people are in controlling, actually, Gen AI systems and LLM in particular. And like, the last point here is that all of these things we talked about, safety, LLM security, controllability, they are dependent on language. And some of them are very language and context specific. Now, some things which are unsafe in Romanian are very Romanian-like. You need to be grounded in the Romanian history and landscape. And I'm just saying that until now, as far as I know, there has been no study on LLM safety in Romanian. Not only is there is no study, there is no data set in order to assess the performance of, or the safetiness for Romanian. We do have some Romanian models which are open, and we know the data that they have been trained on, which are released by the Romanian NLP community. but we don't have anything on safety, on LLM security, on controllability. And I'm saying that this is kind of the same for many European languages. There is a large European project called Europe LLMs. It has about 60 million euro funded by the European Commission, and I hope that these things are going to happen over there. Okay, thank you very much. If you have any questions.
Thank you very much, and with a bonus for keeping the time and doing everything so quickly and so densely. We have another question here from Florin Păun. Make it brief, the answer should be brief, because we are running out of time.
We call it the technological paradigm. Who's the guilty guy? The guy who hit with a hammer, or the guy who produced the hammer? And one of your last conclusion, where you wrote, is the responsibility of the model developer in how he's programming the AI to work. It's shifting this paradigm to the guy who is producing the hammer. And that's really with a huge impact on humankind in a way.
Yeah. Very briefly, because I think we all agree on this. Go ahead.
Oh yeah, sure. You are completely right. Like I was just saying that model developers have a huge responsibility, and okay, model developers and the users and developers of the applications using the models. Yeah, but model developers on my side, they have a very important responsibility to a certain point.
Well, that's the problem.
It depends on the application. Like, if you have an application, it's the same, like, it's a person that is building the application, like, using the hammer is the application. No. But I think model developers are very important. No. Yeah.
This is why the Inquisition was so great as developing large language models and sticking to the norms and enforcing them. This is one of the chilling aspects of this discussion about the regulation of LLMs, because words such as censorship and words such as conformism and things like that show up immediately. But we move to the next presentation by Petre from the University of Turku, who is going to entertain us with a discussion about the AI insights from the PISA 2022 data. Ion.
Thank you very much for the invitation. I'm really excited to be here and tell you about this work we've done. So I'm a professor of mathematics at University of Turku in Finland, and I want to start with this confession that I have an interest in education. And in fact, I spent my whole career so far in research and education. And I've seen up close the education system of 3 different countries. Romania, I'm a graduate of University of Bucharest. Finland, where I spent my entire academic career, and the US, where I spent some time as a visiting professor. And my observation is that even though all educational systems in the world have the same sort of high-level objectives to offer a broad and high-quality education to as many as possible, it's really fascinating to see how diverse their approach to delivering these objectives can be. So, for example, you can have some countries believing in education in a stratified fashion, meaning that they want to see kids grouped by the level of their skills, by their interests, by their abilities. There are special classes, special high schools. On the other hand, you have countries that believe in the value of heterogeneous classes. There is value in diversity of skills and abilities. You have countries that believe in regular standardized testing, and they use them as a filter in the academic path of educating kids. There are other countries like Finland, for example, that really has no standardized testing and sometimes no grading at all. You have countries that, for example, are working on teacher-centric and very strict curriculum, as opposed to other countries which are much more based on open discussion and student-driven and project-driven sort of learning. And so for a while now, I wanted to explore the question, what exactly in the background of a child is predictive of their academic performance? And how does it differ from country to country? And in fact, how does it differ within a country depending on different sort of population stratifications? So in other words, what exactly really in the background of a child is really most predictive of their academic path, and in a sort of actionable way, what kind of measures one could take to improve the academic level of kids on a national level. And I had last fall a number of international students working with me, and I proposed to them to take a look at this project. And so in this talk, I just want to tell you very briefly about the results and what we learn about the diversity of humanity in the context of education. That's what the story I'm going to tell you is going to be about. And so we decided to take a look at these two questions. On one hand, we wanted to know what are the key factors behind academic success in various countries, and how do these factors vary between countries and between socioeconomic stratifications within a country. And we had several hypotheses. One hypothesis was that artificial intelligence and machine learning can help explore these questions. And I'm going to explain to you how exactly we transform these questions into something that AI can help with. We also had as a hypothesis that there are probably major differences from country to country, and there are also significant differences within our country between various stratifications. And I'm going to tell you a little bit about what kind of stratifications we looked at. And we also thought, as a hypothesis, that we are going to find homogeneity across countries with, for example, similar cultures, similar GDP levels, and also we might see similar factors across similar social categories. And so our approach was to look at the PISA 2022 results, which were published in December 2023. And the reason why the PISA set is good for looking at this question is that it's an extremely rich data set. And I want to show you on the next slide what people really usually think when we mention PISA, and then I'm going to tell you that in fact there is much more behind PISA that is very rarely spoken about. So this is a figure of, a map of the PISA countries and economies that participated in the 2022 data set. So there are 81 countries in that data set, about 600,000 students, and the test was focused as usual on results in mathematics and reading skills and sciences. And the PISA test is really by far the best known assessment of the educational systems worldwide. It's very influential in national debates about academic quality. There are sometimes ministers of education that are being fired from their jobs because of the PISA results. There is sometimes a heated discussion in the society because PISA has this sort of flavor of a sort of like an Olympic game competition where there is national pride on the line and you compare yourself against your neighbor or against your favorite, frenemies around you. You also look at the results, how they evolved from the previous PISA cycle and so on. Just as a parenthesis, the 2025 PISA data is just being collected, or in fact it has been collected this spring and is going to be made available at the end of 2026. So when people look at PISA, typically they look at such plots, and they are, this is what gives excitement in these debates about education. So for example, the typical readout of the PISA results is in these statistical distributions. For example, how performance varies between countries. In other words, what's the country ranking and how do you compare yourself against others? How performance has evolved from the previous cycle, and that will give you a feedback on whatever academic reforms maybe were done in the country. This is taken directly from the PISA report done by the OECD. And these are just some excerpts that people usually look at. What percentage of students can do at least basic math and dynamics from cycle to cycle, and some observations about disadvantage, socioeconomic disadvantage, and how that plays a role in the academic results and so on. Now, what we wanted to do was, in fact, to go beyond these results. And we wanted to know on an individual level, on the level of a child, or of a student, what exactly does it explain how they did, and what exactly could be changed for a hopefully improvement in their results? And the reason we can ask this question based on the PISA results or the PISA data is that the PISA data set has in fact a lot more information than what people typically look at, which are plots like this. And in fact, in the PISA results, we know about every single child. We know how they did in the math, reading, science results, but we also know the answer to about 1,000 questions about their background. And some of these questions are very intimate, very sensitive. It's about their family, it's about their life experience, it's about their school experience. We know things about their teachers, we know things about their parents, about the economic level of the family, we know about their schools, and so much more. So these are some examples of things that we know about every single child that ever takes the PISA test. So for example, we know the answer to questions such as, do you have a quiet place to study at home? How many bathrooms do you have in your home? What's the highest level of education that your parents have achieved? How often do your parents talk to you about political or social issues? Do you have access to a computer and the internet for schoolwork at home? What kind of job do you expect to have when you are about 30? Also, were you ever late for school because you had to take care of a family member? So these and many more, in this PISA test, there are literally 1,300 questions that every single child, we get information about. So we wanted to basically answer the question, what exactly is predictive of their academic performance, by thinking of this question in terms of a machine learning problem. In other words, we had as an output their math, reading, science results, and as an input or as variables, what we know about their background, is essentially the answers to these and all the other questions. So the first question was, can AI help with this problem? Can we do anything about it? Can AI, in other words, learn to predict the PISA results based on a student's background? And the answer is yes, and we've tested this in lots of different variants. In fact, each one of the students that worked with me on this project, each one of them got to train about 100,000 models to explore this question in all kinds of different setups. So the answer is yes, it can be learned. And then we wanted to check this specific question, what are the factors, what's important in terms of having good results in a PISA test? And we looked at this question and we tried to find patterns. And we've done really quite a lot of analysis. On one hand, we wanted to have a sort of a worldwide pattern. Is there something that's common, to all the countries in the world? Then we checked, what about the OECD countries? On one hand, what's common to them as a pattern, what's common to the non-OECD? We wanted to check patterns specific to various GDP levels, country-specific analysis, and for some countries, depending on how they collected the data, we were able also to do some country stratifications. For example, we checked urban versus rural, whether kids come from the city environment or for some rural, geographical distribution, socioeconomic status, and so on. There are lots of results. I'm going to have just, I think, 4 or 5 snapshots of what we got, and I'm going to comment. Essentially, the only, sort of lesson to take home from here is that there is a lot that can be learned in terms of actionable, points that you can take from this PISA data set. So here is the first one that I want to show you. We checked for patterns in the OECD countries and to compare with non-OECD, about 300,000 students in each one of these categories. And in the non-OECD, the patterns were decidedly simplistic, meaning that probably there is a lot of heterogeneity. There are not too many common patterns across the non-OECD. They are too diverse, in other words. So we did find something that's really common to them as a pattern. For example, how much you spend in studying mathematics, how many digital devices you have at home. On the OECD side, countries are much more homogeneous, and so we were able to find out some interesting patterns, and this is, I'm going to show you a few surprises. So some of them I anticipate are going to be about Romania, but this is the first maybe surprise that I want to talk about on this slide. When you think about the important factors in explaining the results in mathematics, for example, I'm not sure that you would necessarily think about this one, which is the answer to the question, how many books you have at home? And also the answer to the question, how many books of contemporary literature you have at home? And yet we found that this is in fact really predictive of the results in math, and not only in math, but also in reading and science. This was a common factor across all of the results in the PISA test for the OECD countries. Now, I'm just going to give you my own interpretation why this is important. So, for example, if you take a look at the contemporary literature and the question about do you have books from contemporary literature at home, I think that this shows a number of things. On one hand, these are not the compulsory reading things that you get from school. These are books that your family bought, for you, which means that there is enough money in that family to invest in culture. There is enough of an understanding of the value of culture, and there is enough support from the parents thinking about, what their kids have at home. There are also things that are, specific to individual categories. So, for example, in math, we found out that the socioeconomic status is very important, but also the gender is important. And I just want to give a short explanation about this so that this is not, interpreted in the wrong way. The gender being important means that there are different sets of motivations for boys and girls. And that has to be taken into account. What motivates one category does not motivate the other way around. So the gender is important in explaining, how they do in these categories. And for example, there is also the answer to the question, I do share made-up information on social networks without flagging it as such. That was also predictive of the results in reading, meaning, this is an insight into their analytical skills, for example. So here is another set of results. We took a look at the low GDP countries, and I have here, there are lots of other countries in this category, but I have here just 4 examples: Argentina, Mexico, Jordan, and then Guatemala. And again, I want to show you a few snapshots, patterns that we found, and things that we found specific to each one of these countries. So, for example, patterns that we found throughout all of these low GDP countries is whether they had access to one-on-one tutoring with a single person. And another one was the gender, but gender I explained on the previous slide. Again, the different set of motivations that seem to play a role. But here are also specific factors to each one of these countries. For example, in Argentina, there is something about having or not having a smartphone with access to internet and being able to use that for doing your homework. And also the question of whether you practice a sport. That was important. And in Mexico, for some reason, creativity is very important. It came up in 2 different questions, and can you explain creativity just to arts, or can you be creative in any other subject? For Jordan, for example, there was a question of whether you have enough money, to buy food. That was predictive of their results. Here is the other category where Romania also comes in, the category of below average GDP. I only include in here the results in reading and science. The mathematics results are very similar in terms of features that are explained. And again, in terms of common patterns across these countries are things that we've seen in the other categories. For example, flagging or sharing information on the social networks without flagging it as such. But I want to maybe show you what we found out, for example, about Romania. Maybe I skipped the other countries. So in Romania, for example, we found out, sadly, maybe, that one of the most predictive factors for the PISA results is whether in the last 30 days there were occasions in which they went to sleep without eating because there wasn't enough money for food at home. And this we found both in reading and in sciences. Then I just want to give you a very quick fly through, just basically to make the point that an analysis can be done much more detailed, and I want to tell you about the Finland. Finland is very often, exported as a model for education, and there is a lot of diversity when you look inside the country, depending on various, stratifications. For example, urban versus rural. We had common patterns, for example, attitude to mathematics, whether they consider the mathematics to be easy for them or not, digital devices at home, books in their home, things that we've seen before. But there are also things that are specific to the urban environment and things that are specific to the rural environment. In the urban environment, you have the question about immigration. How old were you when you arrived in this country, and what language do you speak at home? And that's because the immigrants tend to establish themselves in the urban environment and not so much in the rural environment. Interestingly, in the rural environment, what we found out for Finland is that the level of the education of the father plays an important role. I didn't comment, but in Jordan, for example, the level of the education of the mother was important, but in Finland we found that there is something about the father, but only in the rural environment. Here is just one more slide, and I'm going to just skip this and just basically give you the point that we can do this much more detailed in terms of geographic distributions. We did this in the capital area, southwest, northeast, and for the Swedish speakers. And again, very interesting insights. I only comment on one thing. For example, for the Swedish speakers, we found that the questions about whether they have works of art at home is important and predictive, because this associates with the old stereotype about the old money associated with the Swedish minority, and works of art are reflective of that. So this is what I wanted to tell you about. These are just the conclusions, and then I have one slide to leave you with. So what we found was that the AI offers a deep insight in the human aspect behind education, on the interplay of social, economical, cultural, and academic variables. And we also found out that there is a lot of diversity. In other words, academic success is highly contextual, and policymaking must consider local socioeconomic and cultural factors. And when you import academic models, even if they come from Finland, where I come from, that has to be done carefully and adapted to the local conditions. And there are surprising findings that we got regarding aspects supporting academic success. Some of them are far removed from academia itself. And so I just want to leave you with this final slide about general lessons. So what we find out from the PISA set, and this seems to be applicable everywhere with different details. On one hand, more reading helps. Then family support matters a lot. There is differentiated motivation in boys and girls that has to be accounted for. Better inclusion of immigrant or disadvantaged students. There is an economic divide that really explains the PISA results. Practicing a sport is important, and the use of digital tools in schools and outside. Thank you very much.
You start looking into education and to find society and the world. That's the surprise. Thank you very much for this comprehensive presentation. And now we break. We break until 4:30 exactly, because we want to go on with the second session. Thank you. There are refreshments out there. Please.
de istorie.